morning, everyone. In our previous class, we have started chapter 14, that is chemical effects of electric currents. We have done the introductory part in this chapter with the definitions of conductors and insulators. We have seen the circuit tester and how we can check whether the given substance is a good conductor or an insulator. That we have done in our previous class. We have seen some examples of conductors and insulators as well. Now today in our class we will discuss about the conductivity through liquids, the electricity through liquids. So as we have seen in the previous class, where various solids like metals, they show the conductivity. Similarly, some liquids are also there which show the conductivity of electric current. Okay, so here are some examples, like if we are talking about the tap water, salt solution, hydrochloric acid, sodium hydroxide solution, etc. All solution of acid, base and salts. All the liquids show conductivity. Some other liquids are also there which do not show the conductivity. So how can we check whether the solution or the liquid is a good conductor or not? As we have done for the solid, same we can use the tester for the liquids. We will use two terminals which are attached with the battery and the bulb, and then we dip the terminal in the solution, and then we switch on the electric current. We switch on the battery. So if the bulb glows, that means the given liquid conducts electricity, and if the bulb doesn't glow, that means the solution does not conduct the electricity. Okay, same type of activity can be done. But if we are talking about the solids, and if we are comparing the conductivity of solids with the liquids, so the current produced by the liquids, or the current passes through the liquid, that is very weak as compared to that of solids. So the amount of conductivity is less, we can say, and that's why the electricity which is required to glow the bulb, that electricity is not produced in the case of liquid. So if we use the normal bulb, so that may happen that the solution is a good conductor, but the bulb will not glow because that enough amount of electric current is not there. So that's why, just to avoid that confusion, we should use another type of tester which is able to detect the weak electric current also. Okay, and for this purpose we can use two things. The first one is LED, that is light emitting diode. Okay, light emitting diode is also a device which requires a very weak current to just heat the filament of the bulb, and the bulb will start glowing if weak electric current is passing through the filament. Okay, it doesn't require a very high electric current. So it has two leads which is also called as wires. The one is slightly longer than the other one. The longer one is known as the positive lead and the smaller one is called as negative lead. Okay, so this LED, because it requires a very weak electric current, and the bulb can glow easily with the help of this weak electric current. So that's why somehow it can also help to reduce our electricity bulb. And that's why nowadays in most of the houses we have displaced the normal bulb by that LED bulbs and LED tube lights, because their consumption is very less. So that's why we can save our electricity bills also. Okay, so this is the first way to detect the weak electric current, by using LED bulbs. Now another one is magnetic compass. In class 7, you have discussed about the magnetic effect of electric current. Wherever electric current is there, so it produces some magnetic effects also, and because of that magnetic effect we can observe the deflection in the magnetic compass. Okay, so we can use the magnetic compass to detect the weak electric current. In the book you can see activity 14.3 is given, where you can observe that uh, movement in the magnetic compass, that is just because of the magnetic effect of electric current. Now basically we have to discuss the chemical effect of electric current. In this chapter main thing is that what happen when the electric current is passes through the liquid. So when we pass the electric current to the liquid, and that liquid actually dissociates into the ions, and then these ions will move towards the oppositely charged terminal, which are also known as electrodes. So these charges will move towards the oppositely charged electrodes, and there they will discharge and start depositing over there. That is exactly the chemical effect of electric current. Basically we are having two examples of the effect, chemical effect of electric current. The first one is electrolysis of water, and the second one is electrolysis of copper sulfate. While we are using the electrolysis of copper sulfate, in the same time we can have the electroplating process also. So first we will discuss in common what is the chemical effect of electric current. You can see in the diagram the labeling is given cathode and anode. Okay, this is the setup for electrolysis experiment. We required a battery which is used as the source of the electric current. Then the two terminals are required. Okay, the one which is attached with the positive terminal of the battery, that is named as anode. The another one which is attached with the negative terminal of the battery, that is known as cathode. Okay, the one which is attached with the positive terminal, that is known as anode. The one which is attached with the negative terminal, that is known as cathode. So cathode is the negative electrode and anode is the positive electrode. It is very clear from this diagram also. You can see anode is attached to the positive side of the battery and cathode is attached to the negative side of the battery. Okay, so negative terminal is cathode and positive terminal is anode. Okay, now when we pass the electric current through the electrolyte, now what is electrolyte? Electrolyte is the solution which we are using to conduct this particular experiment. The liquid through which we are passing the electric current. That liquid is termed as electrolyte. Okay, electrodes, these are the terminals which are attached with the battery. Positive electrode anode, negative electrode cathode. Electrolyte, that is the liquid through which we are passing the electric current. And that whole setup, which includes that anode, cathode and electrolyte, that whole setup is termed as electrolytic cell. Okay, now what is the effect of electric current on the liquid? That electrolyte is generally a compound, aqueous solution we can take, or we can take the molten state of the compound. Okay, liquid is required. So either we can take the aqueous solution of the salt, or we can heat the salt till its melting point so that the liquid state can be used. That is electrolyte. Now when we pass the electric current through this, so that substance will splits up into the ions. Positive ions, which are known as cations, and negative ions, which are known as anions. These ions will move towards the oppositely charged electrodes because opposite charges attract each other. So positive ion will attract towards the cathode, negative ions will attract towards the anode. That is exactly the chemical effect of electric current. In the next class again we will discuss the process of electrolysis with the examples of hydrolysis of electrolysis of water and electroplating of copper sulfate. Thank you.